In this video, we're going to compose two functions and look at their domain, and we'll compose them both ways. Now, first off, we should find the domain of each function by individually, if there were no context. Well, this one's pretty easy. X just can't be 0. So it's negative infinity to 0, union 0 to infinity. This one, we know that x minus 4 has to be greater than 0. Add 4 to both sides of that, you get that x has to be greater than 4, greater than or equal to. So the domain is 4 up to infinity in our interval notation. That's important because whichever function goes inside first, we have to observe its domain. So for instance, if we're doing f of g of x is going in first. We already know no matter what happens when we simplify at the end, x cannot be 0. So f of g of x, we're going to put g into f, so that's f of 1 over x, which is square root of 1 over x minus 4. Alright, now first off, notice that we're subtracting off 4. So 1 over x has to be positive. It can't be 0, because 0 is not in our domain. So 1 over x has to be positive, which means that x has to be positive. So x has to be greater than 0 already. We can see that, because this piece here has to be positive. Now we also know that 1 over x minus 4 must be greater than or equal to 0. Well, let's treat this like an equation. We'll add 4 to both sides. We get 1 over x is greater than or equal to 4. Now let's multiply both sides by x to get rid of this denominator over here. So we have 1 is greater than or equal to 4x. And finally we'll divide both sides by 4. So x has to be less than or equal to 1/4, excuse me. Remember what we said, we already know that it has to be greater than 0. Because if it's any less than 0, this will be negative, and we have a negative minus a negative. Under the radical, it can't happen. So we know that we have a very small domain for this composition, and in fact the domain for f of g of x is going to be 0 with a parenthesis because we can't use 0. So we'll move this up a little bit so you can see it. There we go. Up to 1/4, but it can be 1/4 because when we put in 1/4, that's going to be the time when we get 0, which is okay. So there's our domain. So a little tricky on that one. Remember, you always have to observe the inside function's domain, and then you compose them and find out what the domain of the composition is. So let's do g of f of x. So that's g of square root of x minus 4, or 1 over square root of x minus 4. Now we already knew the domain of square root of x minus 4. It was that x had to be in between 4 and infinity, including 4. We have almost the same domain, because we still need it to be positive. The only difference is now we need x minus 4 to be strictly greater than 0, because we can't divide by 0. So we can add the 4 to both sides. We get x is greater than 4. So our domain in this case is 4 to infinity, not including the 4. So we have to look at the domain of the inside function and then the domain of the composition together and find their intersection. So that's how we can find domain of a composition.